Hi, we're team number 2, confirmed by Hyun Chong, Sofía Lizalde, Javier de la Victoria, and me, Loretta Esparza. For this project, we need to investigate and get a function in a newspaper or a magazine. So, we found these articles. All talk about the coronavirus. The first one titled is this: Why the coronavirus spreads exponentially, the R rate meaning, and how to fly the curve in Ireland. This report talks about the exponential growth of this virus in this specific country, and it shows us the graph of 25 days of this virus growing. The second one shows us the total coronavirus cases in China, the number of deaths, and the recovered. Also, it shows us a lot of different graphs with different information per day. The third one title is this: A different way to chart the spread of the coronavirus. Here, it talks about the behavior of the virus in different forms of graphing in USA, compared with the behavior in Italy. Finally, we choose this one, the exponential power of now, that my partner Javier is going to explain.
We choose the exponential power of now, that explain some statistics about the coronavirus and the number of cases according to a specific day. We wanted to work with this new because coronavirus is a situation we are living now and it is a global problem, and also because it was easy to find statistics and information that could be expressed in mathematical language, and we did it through a function that explained how those infected people cases increase according to the time.
The first two we have are the verbal and the algebraic one. The domain represents the number of weeks that we are considering, and it is the constant variable. The number of infected people changes according to the time that passes. According to the time it passes, the number of cases is going to increase and it's going to change. X represents the time and Y represents the people infected. In the algebraic form, we have f of x is equal to 0.2813 x to the 6 minus 7.4793 x to the 5 plus 78.006 x to the 4 minus 402.87 x cubed plus 1068.6 x squared minus 1346.9x plus 611.22. The third way to express it is the tabular representation. On the first column we have the time, in this case x, but it's represented like t of d, and in the second column we have the number of cases, that in this case is y, but it's represented as d. As we can see, the cases depend on the time it passes, so we can say that the time is constant, but the cases are not. Finally, we have the graphic representation. In the y-axis, we have the cases, and in the x-axis, we have the weeks. It is easier for us to understand how it changes. In a graphic way, you can interpret in a better way how the virus spreads and how fast it travels.
Well, as a conclusion, according to the questions 6, 7, 8, 9, and 10, we could make a function that describes how fast the virus spreads. The polynomial tells us the number of cases according to the specific time. Also, we can explain how the function depends on the independent variable, because the more time that passes, the more cases there will be. According to the question number 9, we saw that the minimum is 0 and the maximum is infinite, and we also observed that there are no intervals where it's decreasing, but they're always increasing, such as 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, and 9 to infinite. Finally, we think that the newspaper doesn't present the information in the best format, because it just gave us some points but not enough information such as the exact equation. Anyway, with it we could make a polynomial function.